Howdy tubers, I got us another little project here. This is a little bitty, like a national size 6 or something pump unit, an arm. This thing runs real slow. I took this apart last summer and it sort of turned into one of those downhill projects, and I hadn't fixed it yet and I need to. I busted a big chunk off this arm when I tore this apart, and I thought at the time this was probably junk and I was going to have to find another one. And I think I'm gonna be able to put this bolt in the other way and just let this bolt, I think it'll catch on this. You know, I know there's a bunch of gone here. I think it'll catch here. I might have to braze the head of the bolt on here. But the wrist pin also had, I've got the other two halves of this. It's got a plate that goes on either side. The back's got a seal and the front's got a greaser in it. And I think that it ruined one of the sides and not the other. I hadn't looked for it. It's just laying in my shop somewhere. But I needed to measure this and see if I could press this out. This pin is pressed in this crank arm that's got a Allen head screw right there. This may be somewhat of a trick to get out. Anyway, I was just going to kind of pick my camera up and start on this, and I may have to have some plates, cut some plates out, or have some water jetted plates to make the sides of this wrist pin. But let's see what we can get started here. See if we can make something out of nothing, or something out of not much. Okay, I got all the parts to put this together. I found both of these end plates. So these end plates bolt on here just like this, and the bearing is sandwiched in the middle, and then the seal pressed in right there. This is the only one that's screwed up. It did get into this housing just a little bit there, but I think it's fine. Basically, we got to make a new one of these. I torched out a piece of plate to make it out of, and we got to make a new shaft. All right, the next thing was we got to make a shaft. This shaft has got a couple of critical dimensions. It's press fit only. It does have a bolt that screws in the bottom, but in my opinion, those don't do much. Anyway, we need to measure this. We need to get a really accurate measurement, and then we'll add about 3/1000ths of an inch to this, and that's what size will make that shaft. When we press this in here, it should be, 15 tons or so to push it in, and that'll hold everything really nice and tight. Okay, so to accurately measure this, we're using a telescoping gauge. I forgot what these are called, gauge I think, and a micrometer. These micrometers, these are cheap Chinese micrometers. I do have some nice American made ones. In my experience, these are just as good, and if you drop them, you just go get another one. You don't have to worry about ruining something that's 60 years old. But every revolution of this is threaded. As you can see, it screws in and screws out. Every revolution of this is 25/1000ths of an inch. And you can see a gradient on here. This would be 1,000th, 2,000th, 3,000th, 4,000ths of an inch. It's got this little sort of like a torque wrench top deal on it. This lets you run it in so that you get an exact tightness every time. I don't generally use this. I just do it by feel. Let's just grab the 1 inch. Let's just take a measurement of something really quickly. We'll see how thick this piece of beam is here on my press. So we're 0 inches, because this is a 0 to 1 inch. 0.6, and this is 1,000th from being 50. That's 49/1000ths. So we're 0.649, and then it's got a veneer scale on it, and we'll look at which of these marks line up the closest. And it looks to me like it's probably between 6 and 7. And so that would add another decimal place. So this is 0.6497 inches wide. But obviously what we're really interested in is this. Now you've got to take into account, you know, this usually galls a little bit. You need to kind of feel around in here, make sure it's smooth. Pick out a good spot. We're going to sort of measure this in several different places because we need a measurement within accuracy with inside a thousandth, hopefully more like within about 2/10 of a thousandth, 2/10,000ths. So how these work is they're spring loaded. When you open this up, they pop out. So we'll collapse it, tighten this up, open it up here and release it, and then snug it back up, and we will cam this over inside that bore. And what that does is it squishes these together to the exact width of this hole. Then we're going to come in here and measure this, and I'm going to probably not come, it's probably not going to come through great on the camera, but I'm going to hold this and sort of work it around with my fingers and slowly tighten the mic up until I can just feel some drag on this telescoping gauge. It's a little bit too much. It's a little bit too much yet. I can just feel it sort of hang up as we get it perfectly straight across. You know, I'm just kind of working this in a really small arc. You probably can't see it real well. We're trying to find that perfect thickness. And so, all right, so we are 1 inch, 0.375678. Not quite 8. We'll call it 1 inch, 370.567, and about 8/10. Okay, because I think in thousandths, we're going to make this a little bit more round number. We're going to call this 1 inch, 377 thousandths and 1/2. Okay, we want this to be at least a 2/1000ths press and maximum of 3. And so we want to add to this 2.5 because that's going to be our number. And we would end up with 1 inch, 0.379. This would be, I can't add, 1 inch, 0.380. And this would be by adding 2.5 thousandths to this number. We come up with 1 inch, 0.380. This number has a tolerance of 1/2 thousandths. So we are plus or minus 1/2 thousandth. Okay, we got to turn the shaft here. So the seal that we're going to run is 1 3/8, which is like 5 thousandths less than our target size for the shaft, and that'll be fine. 5 thousandths over, we'll run fine inside the seal. This measures bang on 1 1/8, 1 inch 125. I'm going to be looking for about 1.5 thousandths press fit on this. So this puts it about 126.5 to 127. We just need enough here just for the bearing. I'm really not sure what held this on. Maybe it was just pressed only. We'll think about that though. Let's make this shaft. Got about 15 to go. I'm gonna move the machine in about 14 to 15 thousandths. Better go 14. We'll take our final cut. bit smaller out here on the end, but we're about 79.5. What we wanted. All right, now we got to put the turn it down for the bearing. We're going to 1 inch, 126 to 127. Right on the money. All right, got in the saw. We're gonna let the saw cut the extra off there. Okay, I've got to take and drill and tap the threads in this. This is threaded. The bolts screw into this. This is what sandwiches everything together. To do this, I'm going to take a drill bit. This is not, they're supposed to be 1/4 thread. This is not the right size to the drill for the tap, but it fits the hole in this really well. And so what I'm going to do is go start my hole. And now I've got a good center, so that when I drill this for 5/64, it will center the hole. All right, I'm going to take a 1/4 tap that looks like it's been broke, and I've reground an end on it. Hopefully this will cut. And I'm going to tap some threads here. It's got to start it at least. Excellent. Okay, I got to make a couple of thick gaskets. I probably should have cut some off this ring. This ring sticks out too far. But the tightness of these as they pull together up against this bearing is what takes the slack up out of the bearing. And it shouldn't have force on the bearing. The force should be on the housing, but it should not have any extra slack in the bearing. All right, let's put this thing back together. The very first thing I'm going to do is put the seal inside this seal housing. All right, next I'm going to go ahead and press the bearing onto this little shaft. Well, that ended up tighter than I wanted. It was about 12 tons on that little thin bearing. I hope it lives. It should be okay. All right, next I'm going to drop the outer race on. This one's got paint. Need some grease to put on this. I got some Earl. And then we will press it into the crank arm. I'm going to take a little bit of anti-seize. This is going to be really tight, which it needs to be. Put a little bit of anti-seize on this, keep it from trying to gall or anything. Same with the inside of the crank arm. Well, here's this pretty little jewel. We're fixing to put this wrist pin in. So to get this on here without doing any more damage, we've got to drive a wedge in this crack here. This opens up the board just a little bit so we can slip it on here easier. I have found out the best way to do this. I've had wedges and I've had everything else, and the best way to do it is to take a set of end wrenches, preferably Harbor Freight so you don't care about them, and pick the one that's got the right width head and drive it in there. And the reason for that is if you try to drive a wedge, a lot of times it will try to shoot it back out, and then they're often too long. You can't get them deep enough down in there. Or you can take something like this and it seems to hold better. That's why I broke that thing. It must have been because it's going to be tight. All right, I'm really not sure if this is going to work or not, but if we get the bolt tight, we're going to say it worked. I got to line this keyway up. Hoping that square-headed bolt will have enough there just to catch. It got tight. I don't really see any reason it's going to come out. I'm thinking I could just pull in a stuffing box if I don't pull the stuffing box top off. So they come along. And maybe pull this pick the weights up. The liner looks rough. May not be able to pump this thing. Let me get my grease gun. We got to grease these things. Now this one is not rebuilt, but I did take it apart. I had to get some part numbers off the bearing. I couldn't figure out what the other bearing was, and it is dry. I need to grease it. And these things here are a grease bypass, a pressure relief. And a lot of times they kind of get stopped up, and when you put new seals in these things, it will blow the seal out. And so I pulled that little pop off out of there, and I wanted to fill it up before I restarted it to make sure it'll open. Yeah, see, that's exactly what we want. I believe this thing is ready to go. The only thing I'm concerned about is there is a plug gone out of the top of the gearbox. We're going to have to make sure this thing's not full of rainwater. It's been down at least a good solid year, and it's only 500 feet. I'm gonna have to spray some oil in the stuffing box, and this liner looks bad. I'm not probably going to leave it pumping. I'm gonna have to come over here and change this liner. But let's see if it'll go. Oh yeah, I see the polish rod's not falling. Let me. If you're not familiar with this stuff, it's, I think, a pretty old product, but it's basically like 90 weight or something to that effect in a spray can. It's excellent for a lot of things. It's not very good penetrating oil, but it's good for lubricating, where like WD-40 and stuff is not a good lubricant. Yeah. Well, this is about a month later. I had to do a little bit of bulldozer work over here to clean this up before we get a rig in on it. I had to do a pump change. We had to pull the pump on this. The pump was bad and the liner was pitted. I think I might have mentioned that. I don't remember. It's been a month ago for me, even though it's been 10 seconds for you. Anyway, we did a polish rod, a liner, stuffing box, a used pump and tee. It was new, but it had been in the shop for probably longer than I've been alive, and changed the downhole pump. I was going to try to video that. I didn't have a chance though. The rig came over here and knocked this out for me just in the afternoon, and I was tied up. I didn't get to come over here, but everything's looking good to me. The seal's leaking just a very little bit. It's just got this outside here greasy a little bit. It's been, I think it's been more than a month, honestly. This gearbox had quite a bit of water in it. It had rained in through that little plug that's not there. It's supposed to be a dipstick, and I just wanted to show this got kind of milky at first. It's been a month or so, and it is nice clean brown oil in there. I wouldn't say it's clean, but there's no water, I should say. I've kind of had a lot of people comment that sort of surprises them, that, you know, if you get water in one of these gearboxes or something, and I'm not talking about like, you know, half full of water or something like that, but just, you know, you drain as much water as you can out of it and there's still some residual water, that it'll just stir it up and evaporate it out. It doesn't seem to cause much trouble. Anyway, I'm done with this video. Appreciate you watching. Like, share, subscribe, and well, watch the next one.